All right, so these sum and difference identities are going to help us find exact values of angles that are not the special angles we use to get one, like 30, 45, 60. So, for example, all right, so cosine of 15. If we want the exact value, that means I don't want a decimal. I want to know exactly what the cosine of 15 is. So we can use a sum or difference identity to find the cosine of 15 using stuff we already know. So the first thing I'm tasked to do, the first thing I have to do is figure out which two special angles can I add or subtract to get 15.
45.
Yeah, so I can subtract. The cosine of 15 is the same as the cosine of 45 minus 30. (45 minus 30 is 15.
Cosine A, cosine B, cosine A, sine B thing.
So if you look at your identity sheet, this is a cosine function, and we're subtracting. So we're looking at cosine of A minus B. In this case, 45 is A and 30 is B. So I would rewrite I would make sure to write the formula. So basically, I can plug in 45 for A and 30 for B. And notice I'm writing over here cosine of 15. That's really what I'm looking for. We've established that the cosine of 15 is cosine of 45 minus 30, but at the end I want to report an answer that says cosine of 15 equals, because that's what I was asked to find.
I didn't know that 45, 30.
Say that again.
I didn't know it's not equals 45 and 30.
Well, I just plugged it. The formula is cosine, cosine, plus sine, sine. So I'm using the angles.
So I can just see
If A is 45 and B is 30. So we have a way to find the cosine of 45, the cosine of 30, the sine of 45, the sine of 30. So we should plug those values in. You could either use the unit circle if you're a unit circle person, or you can use the special right triangles if you're a special right triangles person. Okay, so we're going back a little bit. So while you're practicing this, you're probably going to have to reach back into Unit 1 and maybe refresh yourself. The cosine of 45 is root 2 over 2. The cosine of 30 is root 3 over 2. Sine of 45 is also root 2 over 2. And the sine of 30 is 1/2. Okay, so you're either using the coordinates for 45 and 30 on the unit circle, or you're using 30, 60, 90 right triangle, 45, 45, 90 right triangle. Whichever you're most comfortable with. So far, we had to determine what special angles we could add or subtract to get the angle we're looking for the cosine of, 45 minus 30. Then we just picked the appropriate identity off our identity sheet, which you're allowed to have on the quiz and test. Then we got to go back in the file, Unit 1, and figure out the cosine and sine of each of those angles. And now we just have to simplify this. Root 2 times root 3 is root 6. And root 2 times 1 is root 2. No. I can't add the square roots. So I just say root 6 plus root 2 over 4. That's the simplest I can get without getting some sort of decimal, which is not what I want because I want an exact value. That's the answer. So you can always confirm your answer by actually going into your calculator, doing root 6 plus root 2, and then dividing that by 4 and seeing what you get. And then, as long as you're in degree mode, you can do cosine of 15, and it should be the same value. If it is, then you've got the right answer. If it's not, then somewhere along the way we've made a mistake. Okay, a lot of times the mistake is with plugging stuff in. So I like to label that one of my angles is A and one of my angles is B, and then write the identity that I'm going to use, and then plug things in the appropriate spots. Just keep myself organized.
So we have to basically
In this form, how would you have to get something else? No, exact value means this. The decimal you probably have to round. That's an approximate value. No, if you did this example on your identity sheet, then you need to create a new identity sheet. All right, let's do another one together. Okay, so again, I want to find the exact value. If all I was doing was asking for approximate values, then but this wouldn't be a very long class because we just plug it in the calculator. So I like to change my radians to degrees because they're easier to figure out what you're adding or what you're subtracting. So the tangent of 7 pi over 12 is the same as, I'm going to cheat a little bit, the tangent of 105. So I can just do 7 times 180 divided by 12. Pi and 180 are represent the same multiplication of the unit circles. So pi gives it to me in radians, 180 gives it to me in degrees. So 105, not one of our special angles. So I need to figure out if I have two angles added or subtracted. Anybody have an idea? 60 and 45. Okay, so I'm going to ask you this question only because somebody asked me it, or several people asked me it when I did this in my last class. So how do I know if I'm adding or subtracting?
If it's higher than...
So like what, so you said 60 and 45, what would I do then?
Add them.
Because,
Makes sense.
okay, they add the 105. Doesn't matter what order?
No.
So I have tangent of A plus B. 60 by A, 45 by B. You could have it the other way. If you said 45 plus 60, A would be 45, B would be 60. You'll get the same answer. So I'm using So the reason why it doesn't matter which one goes first is because it doesn't matter which order you add, and it doesn't matter which order you multiply. You will end up with the same values. So the tangent of 60 is root 3. Oh, I didn't. I want to make sure I do what I said to do. So the tangent of 60 is root 3. And the tangent of 45 is tangent of 45 is 1. So again, unit circle or special right triangle, whichever one you are mastering. Either the unit circle or the special right triangles is how you get tangent of 60 and tangent of 45. No, I didn't cheat. I actually did this problem before. I like to do them like before class so that I should have an idea. It's 7 times 180 divided by 12 is how I got 105. I don't have a calculator, and I'm pretty sharp, but you know.
So with the square root of 3 and the negative square root of 3 cancel?
No. can't cancel these because they're part of an addition or subtraction. I can only cancel if they're factors being multiplied, which is not true. So the best I can do that's as far as we're going to go. We're not going to mess around with getting the 3 out of this now. If you can do it, do it. This is like, I used your trip as an example. This is like, we're going to drive to Florida. We're going to get someplace really good. And then if you're interested, you can go to Orlando on your own time. I don't need to go to Orlando. I just want to get to Florida. You can go to Disney if you want. We're just going to the Sunshine State.
Where are you going?
Huh? Really go to the Panhandle, the golf club. We got a friend that lives there. Between Panama City and what's the other? Pensacola. All right, try that one.
Wait, come on, man.
All right, so 75 is 45 plus 30, or it's 30 plus 45, whichever you chose. So I would be using the sine sum identity. The way I wrote it, 45 is A, 30 is B, so I make sure I plug them in. We use these values in the first example I did. When you simplify, you actually get the same answer we did for cosine of 15. Yes. So 15 and 75 are complementary, and sine and cosine of complementary angles are equal. I don't need you to know that. I didn't do it on purpose. It just happened. Well, if you have the sine of one angle and you're trying to find the cosine of its complement, then they're equal. I mean, if you know that, you can use it. Oh, it's a fact, yeah. Yeah. Questions before I go into the next type of problem?
There's more. Something easier than others.
Eat the big fish first. What's that?
I still don't understand that stuff. I need to look at it.
All right. So there's one other type of question that we'll do. So in this type of question, I have two angles, S and T. It's all your different letters. I know the sine of one, I know the cosine of the other, and I'm told that they're both in quadrant 2.
Shouldn't it be S and C?
That's S and T. So I'm going to find the cosine of S plus T. So I'm going to use the cosine sum identity. So this is kind of nice because I see a cosine, I see a sum. That is going to send me to take the cosine sum identity off my identities. So the S is my A, the T is my B. I'm going to put the S's and T's in parentheses.
So wouldn't that be cosine S times T minus Sine S times T? Or something like that?
No, I don't see it. So I actually know a couple of these values. We're given the sine of S, so we could plug that value in right here for sine of S. That's 3 over 5. And we're given the cosine of T, so we can plug that in. So far, it's just recognizing its cosine, and in addition, pulling out the correct identity from your identity sheet, and plugging in the values you know from the information. No.
My teacher didn't make me learn it.
So you can use the triangles. The triangles are easy. In my opinion. In my opinion. It's Christmas. You're assuming that I believe that everybody celebrates Christmas. That's not always true.
Let us have 5 minutes before it's the holiday season.
So, we need to know what the cosine of S is and what the sine of T is so that we can proceed.
And when are we going to use this in life again?
This is real life right now. It's happening right here.
So how is it going to help me get a
It's
job?
November 23rd, the year 2015. You are breathing, living being. This is life.
And how's it going to help me get a job?
I don't know. You learn this, you do well on the test, your GPA goes up, you get into a better college. You can write Harvard on your resume, and then, get a better job.
Well, I don't want to go to
All right. So, for my angle S, I have sine. Back from unit 1, sine is y over r.
Wait, Pythagorean.
So we can get x using the Pythagorean Theorem.
4. X is 4.
I'm going to skip the part where I do all this work because you all know how to do this. 25 minus 9 is 16. Square root of 16 is 4. Okay, we are in quadrant 2. In quadrant 2, x is negative. So when we write the cosine of S, we have negative 4 over 5. Negative, we have x over r, negative 4 over 5. For t, we had the cosine, so we have x over r. Okay, if you do this, you'll find that y is 5. Y in quadrant 2 is positive.
What should it be?
Sine is y over r, so we have positive 5 over 13 for the sine of t.
How many questions would you have?
And so now all we have to do is do some simplification. -4 times -12 is positive 48. 5 times 13 is 65. Minus 15 over 65. Yeah.
So we're supposed to be finding exact values, so we're not supposed to be having decimals.
Right.
But basically, fractions and quadrats and everything make it like into fractions, into decimals. So technically, aren't we just writing it in decimals in a different form?
Are we writing decimals in a form? We're writing decimals in a more exact form. It's more exact to say 1/3 than 0.3 repeating. So there are two angles that exist that end in the quadrant 2, and if we added them together and took the cosine of that, it would be the same as 33 over 65. What are the angles? I don't know. We could find out, but we don't need to. So I'm going to have you try that one. And what's nice is we've already done the Pythagorean Theorem bit. We had the same information, we're just looking for a different value, sine of s minus t. So we picked a different identity and we plug in the stuff we know. Alright, so I'm going to give you practice to do today. I'm not going to collect them. On Monday when I see you, I'm going to answer questions from the practice that you might have. Then I'm going to give you some more practice. And then you're going to have a tie. Okay? So I would highly recommend not misusing the time to practice.
Do we talk today or Monday? Monday, sorry.
Questions on this problem? All right.